Here, we're going to find the inverse of this matrix A. And so we notice that A is going to be a 2 by 2 matrix, so that means we can use a nice formula to find its inverse. So in generalized terms, when we have a matrix A whose entries are A, B, C, D, we can find its inverse by doing a couple of things. So first of all, the inverse is going to be indicated with this symbol here. It looks kind of like an exponent to the power of -1, but that's not at all what it is. But that's the notation we're going to use for inverse. Okay, so two things here really that are happening is we need to find the determinant of A, so the determinant of this original matrix, and we're going to put it underneath a 1 and use scalar multiplication to multiply every entry inside here by the reciprocal of this determinant. And what's going to happen over here is you'll notice some of the variables have been kind of rearranged, or maybe the sign has been changed. So this main diagonal that has A and D, the order is going to be switched. So now it's D and A, so we're just going to flip those two terms. And our minor diagonal, B and C, we're going to switch the signs, so -B and -C. So this is the formula we're going to use to find the inverse of a 2 by 2 matrix. And there's one stipulation here, as long as the determinant is not 0. If the determinant ends up being 0, then it's 1 divided by 0, which we can't divide by 0, that's undefined. So the matrix actually does not have an inverse, and we're going to go ahead and call that a singular matrix if that's the case. Okay, so let's look at this first example. I have my matrix A, which is a 2 by 2, whose entries are 3 and -2 and 6 and -3. So the first thing I'm going to do is to find the determinant of that matrix A. So 3 and 6, -2 and -3. So 3 times -3 is -9. And from that I'm going to subtract 6 times -2, which is -12. So -9 plus 12 is 3. So that means the determinant here is going to be 3, and that's what's going to be placed right up here in my formula. Okay, so if I say the inverse of matrix A is going to be 1/3 times, so let's go ahead and rearrange these terms a little bit. So in this main diagonal, I'm going to switch the order, so it's going to be a -3 here and a +3 here. And for my minor diagonal, I'm just going to change the signs. So the -2 becomes a +2, and the 6 becomes a -6. So the final thing I need to do is to go ahead and do scalar multiplication and take this 1/3 and multiply it by every entry in here. Well, this shouldn't be too bad because it looks like most of these terms are already divisible by 3. So 3 divided by 3 is 1, and we have this negative, so -1. So 2 times 1/3 will be 2/3. -6 times 1/3 will be -2. And 3 times 1/3 will be 1. So, given this original matrix A, we can use the formula to find the inverse, which is going to be this 2 by 2 matrix.